Hey everybody, this is RVermil47 coming to you from Dallas, Texas. Today is August the 5th, 2011, and I'm making this recording at 3:49 Central Daylight Time. That's Central Time in the United States. Um, we finally had our major impact today from the coronal mass ejection, and I believe what happened is this was the culmination of the last two that came. We had a little disturbance yesterday, and then today we've had a pretty decent to almost major impact, and we're going to see a geomagnetic storm, a pretty decent one, continue to be in progress as we go through the next few hours. Right now we're looking at ACE telemetry, the data coming from the ACE spacecraft that gives us real-time space weather, or real-time space wind, I believe, is what that should be. But as I've said before, a lot of times I look at the BZ component. That is the north-south component of the wind. It's the like a magnetic north and south. When it's south, it has a tendency to connect with the incoming CME, and we're more susceptible to having geomagnetic storms. Well, when the shock first arrived, actually before 18 Zulu today, a lot of the computers are saying it arrived around 1830. It's like you can just tell by looking at it here that it was about 1730, which that's 12:30 p.m. my time, just a little after noon here in Central and Texas. Anyway, the strength of the wind speed, or the particles, went up fast. There was an update. Went up and are very strong. In fact, strength up to almost 40 is strongest I've seen in a while. The BZ component again is what I look for, and anytime it goes below the midline, the zero, that's when you might as well say our shields are weak, or our shields are almost down. They're not gone, but they're just kind of weak. And now they've consistently stayed weak over the last hour. So the geomagnetic storm now is beginning to finally materialize. Some other things to show is that we went from a wind speed of about 400 kilometers per second, and we've had gusts now up to 700 kilometers per second. Right now it seems like it's about 600. Again, that's a large jump in just about a 4-hour period. The temperature also went up as well of the solar wind, and the density did. So all these are great indications of when the interplanetary shockwave crashed into the spacecraft, the ACE spacecraft, at the geosynchronous level. Okay, here's the magnetometer that's aboard the GOES spacecraft, GOES 13 and GOES 15 reporting on here. And classic, as we look, we had the little hump yesterday evening, which was that very first CME that was ejected, and then we kind of got semi-stable, and I believe that the last powerful CME overcame the second one we had during the day on the 3rd, because we had one on the 2nd, the 3rd, and the 4th. I believe today's hit is from the coronal mass ejections from these 2 days, and quite a large disturbance. Again, this is at satellite level. This is not at ground level. I'll show you that in a second. But this has rattled the satellite so much that they've actually had to adjust the range over here. And that's always interesting when that happens, because it's like generally it stays in a pretty well confined area. But we've got some major, as I call it, gonging going on, because whenever that interplanetary shockwave hits, if our shields are semi-weak or kind of pretty weak, it's going to start ringing our geomagnetic or our magnetosphere. I'll get it out in a minute. So again, this just shows an excellent rendition, like textbook, of an agitated magnetosphere, which means when I look at this, I think, okay, on the midnight side of the Earth, where it's midnight, dark, and you're at a high latitude, you're probably seeing some pretty good auroras at this time. Just because the magnetosphere is so agitated, and in a big way too. Again, if you're on the midnight side of the Earth, with local midnight, you're probably at mostly high latitudes. It's possible even at some mid latitudes at this point you might be seeing auroras, but be on the lookout, because you're going to see those, and as the day wears on, we may get to see some here in the States at high latitudes, and maybe even down to some mid latitudes, depending on how strong this gets. Now this is the actual magnetometer in Boulder, Colorado, here in the United States. So this is ground level disturbance. So once it hit the satellite, which I showed you a few minutes ago, or just a second ago, it hits the satellite, and then we wait for it to arrive at ground level. Well, we can see where it did. This normally is a smooth line. It should follow the dotted lines, because that's normal, or the average, both ways here. So both components now are very agitated. This being the H component, extremely agitated. The D component is pretty agitated too. So again, at ground level now, magnetic conditions are being affected, and in a pretty decent way. The K-index, a guesstimate would be probably guessing by looking at just this and only going by, and this is my guesstimate, but I'd say that K-index, which is the KP index, the planetary K-index, is probably an order of magnitude of probably already 5. And anything above 4 is when we start going into agitation and geomagnetic storming. 5, we start getting into minor to moderate storming, and I'm looking for the K-index to make it to probably at least 7 in the next hour, or in the next 3 hours. So again, this is ground level. The shockwave has smashed into the Earth. Nothing wild, but it's just a very good, again, textbook example when you're looking at any of these charts to see, you know, exactly how strong a coronal mass ejection is when it arrives at the Earth. It's the estimated planetary K-index I mentioned before, and these are 3-hour data. In other words, they took 3 hours worth of measurements and they come up with a K-index. As you see, we're at time for the next bar to be put up. Okay, I expect it to be way above 4. We're going to see a bar here that's either going to be in the yellow, up in the 5s, and I think later on we're going to see a red one. We're going to be above K4. I'm looking at a potential K7, which would be a Category 2 geomagnetic storm, which is a decent size geomagnetic storm. Anyway, this is something to keep an eye on. This helps us look to see what the magnitude of the ongoing geomagnetic storm is. Again, this may work out to be a decent timing for people wanting to see the auroras here in the United States. Again, right now I would just say at high latitudes, but with the strength of this, it's kind of one of those wait and sees, because it's just possible it could be, you know, a decent storm where you see them as far south as, you know, northern Michigan, you know, up in latitudes like that. So we'll keep an eye again. This should be updating in the next hour, and if I see that happening, I'll just go ahead and put out a bulletin on that. But it's expected to eventually jump to at least a K7 here. This is the elevated proton, or this is the proton flux, and it still remains elevated from yesterday's M9.3 flare, and so protons are still running pretty hard at the greater than 10 megavolt range, which is of course the weinies of the protons, as I call them. The greater than 50 has fallen off pretty quick, and of course the big boys have fallen off pretty quick too, but we still have a decent solar radiation storm happening, an S1, at this point. It did make it to S2, but I believe it has dropped in S1 period right now. It'll fluctuate. Actually, it could go back up because sometimes when we have these CMEs reach that have this much energy behind them, we will see enhanced proton activity. And again, this is solar radiation that's incoming. So that's something to watch because, again, that can upset satellites along with the geomagnetic storm. But a lot of satellites have already been moving. I could tell again today by watching the television that occasional drops that were happening, and also in my car I had satellite radio, and occasionally it would drop just quick, and that's not usual. So I knew that they were doing maneuvers to move the satellites into position to get ready for this geomagnetic storm. GPS is probably going to be affected in the fact that it may not be as precise while the storm goes on. Shouldn't be lost because they should have moved their satellites up, again, made maneuvers with them. But accuracy will not be near as good as it would be on a quiet geomagnetic day. Okay, hopefully this screenshot is okay for you guys. The way this screen capture program does it, once I start at a certain screen, I can't make it bigger or smaller. But anyway, this is the geomagnetic storm scale from NOAA, and this shows that what you would expect at different levels. As I said, I know we're at least at a KP5, which would put us in a G1 minor storm right now. What does that affect? Weak power grid fluctuations, easy for me to say. Minor impact on satellites, migratory animals, auroras commonly visible. That's really, no big deal. I mean, we see that all the time. Not all the time, but you see these and they're no big deal. We move up to KP6, which is a G2, we're probably very close to that. Okay, high latitude power systems may experience voltage alarms. Long duration storms may cause transformer damage. Now, I'm not alarming anyone because, again, we don't know how strong and how long this is going to last. Again, corrective actions are having to be taken with spacecraft, just due to when the geomagnetic storm begins, it makes our magnetosphere swell up, and as it does, if the satellites have not been corrected in orbit to kind of move out some, then they can get caught by our atmosphere, which can cause drag and all kinds of stuff. So again, if people weren't paying attention that are satellite operators, then they're going to be sorry they did. I'm saying that we probably can make it to a KP of 7 with this by looking at some of the stuff and seeing some of the forecast data that's out there. That would be a G3 storm. Voltage corrections may be needed at power systems. There's going to be some false alarms, some protection devices. Again, if all the power grid people are prepared, this is not really a problem. What happened in 1989 whenever we had a strong geomagnetic storm that put out Quebec, Canada, because it crashed one of their big transformers, it just burned it up. Again, it was just from not being prepared, not being able to spread some of the power out before it happened. Again, satellite operators, this really could be a problem for them if they've not done any change. It's just that's all there is to it. It's their problem. It's their own fault if they have not corrected for this. Some other systems that could be messed with: intermittent satellite navigation, low frequency radio navigation. High frequency radio may be intermittent. And again, the aurora could be seen sometimes as low as Illinois and Oregon, generally at as low as 50 degrees at geomagnetic latitude. So that's kind of what I'm looking at right now as far as the expectations for this current. As I was saying, if satellite operators weren't paying attention, didn't have heads up, okay, it's their own fault. They're going to lose some stuff, but hopefully they were paying attention. I would hope that power grid people are paying attention, because this is the first of many of these storms to come, but this is kind of like a dry run for the next probably 3 to 4 years of geomagnetic activity. Anyway, again, here I go. I've rambled way too long, but anyway, Everybody take care, and y'all have a good one.